Hello everyone, this is Michael Abdelmalek. Today I'm going to present for you the paper entitled as PSS to RSCAD model conversion for large power grids. I'm going to discuss with you what kind of challenges we have faced and what are the proposed solutions for this kind of problems. This work is sponsored by Electric Power Research Institute under a project sponsored by New York Power Authority and University of Nevada, Reno. So in this specific paper, we're going to focus on converting PSS models of large-scale real bar grids into RSCAD models for specifically real-time simulations on the RTDS simulators. We need that for several reasons. First, this will help us to assess the performance of our system through hardware-in-the-loop simulations. Second, this study will help us to understand the interactions among various system layers such as physical, measurement, and monitoring layers, which will help us in cyber-physical energy system studies. And third is to address the computational power limitations of RTDS and specifically through this complicated model conversion process. In order to achieve this, we first propose a conversion methodology, and then we implement this methodology on the New York State grid model, and finally we propose and provide some of the comparison between power flow solutions and dynamic simulations between both PSS and RSCAD. In the following figure, you see how the conversion process takes place, starting from the PSS model ending up to do the dynamic performance. However, many of these items propose challenges which will be addressed in the following slides. By using the RSCAD conversion tool, we are able to upload the PSS raw file, and the outcome is a disordered RSCAD model. It is very chaotic, and also components are randomly indexed, as you can see in that figure here. This model needs to go through a lot of steps in order to be organized. The first we suggested here is to split the grid into smaller subsystems. As you can see here, the New York State grid is split into 3 subsystems based on the geographical boundaries. And then for each subsystem, each component is mapped based on its geographical location. And so the end up result from this organization and mapping is seen here in that figure, which is a very clearer, better illustrative and visualizable model. The second problem is modeling missing components. Some components such as turbine governor models as well as user-defined ones needs to be modeled. In our proposed paper, we utilize the C-Builder platform in RSCAD and integrated with the control library to build these units from scratch, as you can see in that figure here. Another problem is integration and modeling of renewable energy resources. It's usually infeasible to model each unit individually, and also some units do not have data access. In our proposed paper, we proposed using the generic models in the RSCAD library to scale up wind farms into one equivalent wind turbine. Another problem we faced is the boundary equivalent representation. In order to preserve the grid dynamics between the New York State grid and other states and countries, we use the Thevenin equivalent at the boundary buses to represent this kind of dynamics. The Thevenin equivalents can be represented and calculated through several platforms, such as BSAT, Aspen, or PSS. The following figure shows the equivalent loads and Thevenin sources for that connections. Also, due to aging of RSCAD model as PSS model are updated frequently, we provided and proposed a user-friendly Python tool which is based on a match and compare algorithm. The tool is user-friendly, which compares what is updated in the PSS and reflect the changes on the RSCAD model. The proposed idea has been tested over the New York State grid model and ended up with more than 1600 single-phase nodes. The power flow solution shows that a value of error of 0.27% as a mean error with a maximum percentage error of 4. The dynamic simulation between the PSS and RSCAD are plotted and shown here that the dynamic is very close to each other. In this paper, we propose a methodology to convert PSS models for large-scale power grid into RSCAD. We addressed various challenges associated with the conversion process and proposed some proper solutions. Also, demonstration and validation has been proposed and provided for the New York State grade model. And thank you.